Welcome to another edition of the Sim Racing Garage. I am Barry Rowland. In this episode, I'll be reviewing the Simrig SR1 motion system, the most affordable 4-actuator motion system that is commercially available I have seen to date. Now, it's sporting some pretty good specs here, like 70 millimeters of travel at 100 millimeters per second. Time to put it through the SRG's review process and see how it does. So, let's get to it. I wanted to give you guys a quick look at the packaging that this system comes in. And it's pretty cool because you can actually pick it up by the handle and carry it around. Now, I'm going to go ahead and just open the box. I typically don't do this kind of video, but this is pretty cool the way they package this. There we go. That looks good. Go ahead and take this. Got a nice thick foam pad on the top here. And that's what we see when we open it up. So we have all the actuators here. We have a lot of wiring and looms and harnesses. We've got the kill button and some other things. We also have a power supply that's a level lower than that. And yeah, this piece here comes off so we can get access to everything. It's just a well done package, and I thought you guys would like to see this. So now I'm just going to obviously take everything out, get it on the bench, and then we'll take a closer look at these parts. Let's take a closer look at all the parts that we get in this kit before we actually get to the actuators themselves. Let's look at the power supply. Got to have some power, and this whole system is a 500 watt power supply, even with all these actuators running. And that's really not a whole lot of power consumption, I think. And they're using a really good power supply. This is a Meanwell, which is pretty much the industry standard for good power supplies. And this particular one is a UHP 500R15. And I'll let you guys see the label there, which does 15 volts at 33.4 amps as output. All right. Very nice unit. Of course, this, Meanwell makes good stuff, as we know. And what's cool is they've actually got their own PETG printed parts here that they designed and put on for the mains connection. You can see the mains connection there. And this is a North American mains connection. And for the power output going to the controller box, that we'll see in a minute, also has its own 3D printed piece on that. Very cool, I think. Yeah. And they say that the PETG filament that they're using here is supposed to have some very good mechanical properties. And yeah, this feels very stiff indeed. So yeah, I would imagine this is going to be a problem here. And it's kind of neat the way they've done this. I was surprised when I pulled it out of the box. Now, let's talk about the controller box. And I might do a quick look inside on this. And again, this is 3D printed, as you can see there. You can see some of the patterns that the 3D prints leave. And we'll go around to the back there, and we can see it in here also. Well, let's see. Trying to get you a better look at it without the reflection there. Maybe they can see it there. Has a cool pattern on it. And we have some connections on each side. We have two 8-pin connectors here, and these will go to the actuators themselves. So one plug for each actuator, and of course the power and the data pins are in here. And we also have a 2-pin plug here for the kill switch, and we'll see that in a minute. And we'll take it around the other side. And we also again have two more motor plugs or actuator plugs. USB plug here and a XT90 plug for the power output. So this is what's going out, and we saw here that this will be plugging into this piece here. Right. And like I said, I might pop the top off this, just take a look at it. I'm sure this is their own custom design in here. They designed all this stuff in-house. So yeah, it's pretty interesting that people are starting to do these kind of things. And yeah, Simrig is really breaking some new ground here, I think, by being able to do that all in-house. We get a lot of cables, as you might imagine, and these are 8-pin units. Let's go ahead and pull these out of the plastic so we can see what they look like. They're kind of jammed in here. Come on out, guys. Don't be shy. There we go. Good. All right, get that out of the way. All right, so here we have the cables, and these are going to be a combination data and power cables. And yeah, no shielding on these, as you can see. And again, we have the 8-pin plugs here. They're going to plug into the box over here and then over to the actuator. They seem to be, I would say this is about 1 meter long. So, but the actuators are going to be kind of close anyway, so I think that's going to be plenty to make this happen. And of course we get 4 of these. Yeah, there's 4 of these here. Right. Well done as far as the crimping and the attachments. I like the plugs they're using where you put these in and then it has this little locking white collar that pushes up and snaps onto it. So yeah, everything looks really good here. I mean, very professionally done. These guys are doing a great job. I really can't complain about much. The only thing I would ever complain about is the shielding. You know, I like to see these shielded wires. But then again, at the price point this stuff comes in at, yeah, okay, it's hard to argue with anything. Okay, let's take a next look at the next cable. And this is a longer cable. This is pretty long. I'm not going to roll it out, but this looks to be about 3 meters long. And so this is, again, the other side. You can see it says right there, XT90. And this is, yeah, I use these kind of plugs on my RC stuff, you know, my flying stuff. XT60 is the biggest I've been using, but these are even bigger. These are XT90s. Of course, they're going to be pushing out a lot of wattage, 500 watts through here. So yeah, you want some thick cables. What gauge is this? Looks like this is like a 12 gauge maybe. I don't know if it's on here or not. It doesn't look like it's on here. So anyway, I would imagine this is a very thick 12 gauge, maybe even 10. Right. So let's look at some more cabling. Now this is cool. They're in Sweden where they're making this. The guys all live in Sweden. They're doing this. And I get a nice North American plug here for plugging into my wall instead of a European plug. It's very nice, thoughtful of them to do that. And of course the other end is the usual 3-prong plug that we are so familiar with plugging in our electronics in general. We also get a USB-A to a USB mini USB cable here. And what's nice here is they've actually added some ferrite chokes on here. And these are the clip-on kind, which I really like. And on both ends, not just one end too. So that's going to help eliminate any EMI or RFI interference if we have any. Okay, so let's talk about this guy. This, as we all know, is the kill button or kill switch. And we've seen a lot of these in the direct drive systems and some of the motion systems that I've reviewed in the past. And yes, it's simple. Push down and then we twist it clockwise to release like that. It's back up. So yeah, and there's the 2-pin plug that's going to be plugging into our controller box over here, right? So it's over there. Cool. All right, we also get some brackets. Now these brackets are for the actuators, and they're going to fit on the side of the actuator, and this piece here is going to go along the top of our profile on the rig that we're running, right? So we put some regular M6 bolts through there, and they've got the hardware to connect this. In fact, where's my hardware to connect? I believe this is it. They give us some hardware, which are some let me pull one of these out. 3D printed, I'm sure it's the same PETG. And when we're assembling it, I'll give you a closer look at what we're doing with that. But there's actually a rounded collar there on this flange that I'm sure is going to go into this piece here, I imagine. Or maybe it goes the other way. Anyway, we'll figure it out once we get there. But yeah, these again, these are, you know, you can flex these if you really bend them, but they're pretty darn stiff. In fact, when you're going this way, it seems they're a little bit stiffer. But yeah, again, this is that PETG, and yeah, it feels very, very thick. And it's got some cutouts here even on the back to clear the screws that are on the side of their actuator assemblies. So yeah, very nice. I like what I'm seeing so far. And we also get some feet, and we'll look at those when we have the actuators out here too. And these are very thick. You can see how thick that rubber is there. It's very, very thick. And it's, let's see, how thick is it? Where's my thing? Anyway, let's find out. How thick is it, Barry? Well, we do have a metal washer in there, kind of sitting down inside of it, so it won't give us the exact thickness, but close enough, I imagine. Let's see what we get here. Yeah, 40 mil. And this rubber feels, it's not real stiff. It's stiff, obviously, but you can actually bend the edge of it with your thumb. So that kind of gives me an idea of just how hard these are going to be. And they'll be sitting on the ground. Obviously, we're going to screw these into the actuator shafts that are coming out, and that'll be sitting on the ground there. So that's very good. Rubber insulation are probably going to make it pretty quiet, I imagine. So yeah, we'll have to wait and see though. Looks like it's about an M10 thread on this, but we'll check that later. What else we got? more goodies. We have some more hardware here, and this will also be used to attach our actuators. These are M5 bolts in here, and it looks like they have regular Phillips heads on them. Let's see. All right, so we have these guys here, and that'll, again, the hardware will be attaching because we're attaching these actuators to a 20 series profile. So look at this cute little guy. This is a spring ball roll-in T-nut, but it's a little teeny guy because these are M5 bolts that we're going to be using, and they look to be about 25 millimeters long, I think. But again, we'll check that when we're actually doing the assembly. What else we get? All right, so we also get the usual, some not usual, but we got some M8 spring nuts in here. Let's see if I can pull these out too. And we'll be using this to attach this part right here. And you can see we have a button head type of M8 bolt here. You know, just fit in there just like that, I would imagine. And then we have our spring T-nut that'll fit on the top profile that we'll be using when we actually mount these. It's just another way to secure it. They'll be secured on these 20 profiles, and you'll see that when we're doing it, and also on the 40 series profile on the top of the 4080 piece that runs the length of the cockpit. So two more, we have a contact point, or rather an attachment point here, and here on the actual actuator, and the actuator themselves will be connected to something else too. So it should be a secure, about as secure as you can get, connection there. What else do we want to talk about? I think that's it. I think we covered it. So what we'll do next is, let's take a look at the actuators. So this is the SR1 actuator from the guys at Simrig. And let's talk about some specs first. This thing is capable of actually in concert with the other three as far as a set goes. The weight limit on it is 175 kilograms or 386 pounds. And so they recommend that you use a lightweight profile type of rig to run this on. Probably a P1 wouldn't be optimal, although a P1, I forget the exact weight of that, is like 100 pounds or so, or I think it's less than 100 pounds. But anyway, still you gotta consider, you got the driver, you've got your wheelbase, and if it's a direct drive wheelbase, that's even heavier. You've got your pedals, you got your seat brackets, and things like that. So not everybody is going to be able to use this system, unfortunately. And of course, at the price point this comes in at, I'm not too surprised at the weight limit on it. So yeah, that's something that we're going to have to deal with, if you know, as far as if you want to buy one of these systems. Now, some more specs on this. This has a travel of 70 millimeters on this actuator here, and it has 100 millisecond speed. So 100 millimeters per second rather is its speed. So that's pretty quick, and we have 70 mils. So that's actually more than my D-Box system, and an accuracy of 0.10 millimeters. And it is a 500 watt system. If you saw the closer look at the parts, you already know that. And yeah, this thing comes in at 6 pounds, 6.5 ounces, or for everybody else in the world, that would be 2,910 grams, or 2.9 kilos, almost 3 kilos. So pretty substantial in hand. And again, they're using in the housings here their specially selected good mechanical property PETG filament. And I'm sure a lot of this stuff is 100 as far as percent on infill, like this flange down here. And how it works is we got a motor sitting over here. Let's see if I can get a little closer there. There's our motor, and the motor is attached to a gearbox. Here's the gearbox, and of course the gearbox will have an output shaft. You can see that down there. Let me flip it around this way. You can see a little better. And there it is. And the output shaft is going into what they're telling me is an aluminum cogged gear inside of this housing. And it will be running on a toothed piston here, or shaft, or whatever you want to call it. And you can almost see it. Let me see if I can get a shot of it for you there. See right there? You can see my white shirt. And you see the groove, the little indentation down here? That is one of the teeth, I think, or the last one that the gear is moving. So yeah, and once we're running it, we'll be able to see that better because it'll come in and out, and we'll be able to see it a little bit better that way. We have what looks to be like a breakout board right here. And of course, we have our plug here, and if you watch the closer look at the parts, you would know that that's the 8-pin plug that's going to be getting the data and power to our units. Now, again, 3D printed a lot of this stuff throughout here, it looks like, and except for this part. This looks to me to be like Delrin, a really tough, hard industrial plastic that you can CNC machine pretty easily. And the reason I think that it is Delrin is because they've actually bored a hole in it and tapped some threads into it. See the threads there? So of course that's going to be for our rubber feet to go into, and that's what everything will be sitting on. Well, there's not a whole lot else I can show you here with this, the way this thing is made. We have the connectors up here, or the little places here that we're going to be connecting our PETG brackets to. And these brackets, if I don't drop it, have these indentations on the back there. So they made these pretty well. And what that is for, so it fits up against this, and it'll actually go flush with it. If I can get it to work, there we go. And you can see everything's lined, well, get my fingers out of the way. See, everything is lining up there. And these little indentations are fitting these screws that they're using to assemble the actual box here that's containing this piston or shaft that's being moved up and down. So yeah, and as far as noise, I don't know. We kind of get it up and running as far as that's concerned. And yeah, not a lot else to see here. I'm not going to tear it apart because I might not be able to get it back together. Then I wouldn't have a motion system. So it's just one of those things you got to be careful. So yeah, anything else I want to talk about here? Not much. It's all I want to do really is get these things on and start using it. So yeah, I think what we'll do next is just go ahead and mount them to the, we're using a rig that also came from Sweden, which is a Swedish Rig Designs. That's the company's name, Swedish Rig Designs. And I'll be running that on their rig, right? So I'm kind of doing a double video, but not really. It's two different videos, but there'll be a little bit of overlap because of that. But anyway, why don't we go ahead and see how these things get mounted up, and when we come back, we'll have them mounted up, and I'll talk about how that went. So we have all four actuators mounted to their 20 series profile pairs, and it wasn't that hard to get this done. Now in the instructions they tell you to flip this whole chassis over. Of course I've got the wheelbase on there, so I wasn't going to flip mount over. Of course you could have taken it off and flipped it over, but it was already sitting up on the blocks, and yeah, made it for not that hard of a thing to do. It is a little fiddly, and I will show you guys some video clip here, some b-roll of me sliding those T-nuts into the profiles. And yeah, I left one profile of the pairs a little loose so I could slide it back and forth longitudinally across the chassis, just so that I could get them in easier, and then tighten everything up after that. So yeah, again, a little fiddly, but you know, obviously it's doable, and even when it's not flipped over upside down. I still would like to see some kind of a bracket that you could just mount to the side of these 4080 profiles on this cockpit that would do the same job of capturing those flanges on the actuators. Just make things a little bit simpler, I think, but hey, it still works. Right, so I'm going to also go over here and take a look at the next thing we had to do, and that was these brackets on the side that offer support to the top part of the actuator. And yeah, those are M8s going into the M8 T-nuts in our profiles, and then we have those screws and the nuts going in with those. Remember those 3D printed pieces? Well, this is showing up, but there they are, and they go on the back side with the nut and the washer. And everything tightened up really well, and then once I was done, I went under and tightened up the corner brackets that were supporting the ones that were loose to help me get the actuators on easy. So everything is nice and tightened up now, and my camera is actually level right now. As you can see, the cockpit is not level. It's not your imagination. This actuator on front is actually a little higher than the rest of the actuators, which is not, you know, it's just the way it was shipped, that's all. I'm sure once we power this thing up, they'll all level out right away. That's typically the way the boot up software runs on these controller boards, so it just centers them as soon as it starts up. But we'll see that once we do that. So that's it. Yeah, now we got to get the controller box mounted onto the profile, and before we actually mount the box, I think we should actually take a little peek inside of that box and see what's in there. Let's take a look inside of the controller box for the Simrig SR1 system. And I've already taken the screws out, obviously, and we have a 3D printed cover that has a tab on it. See the tab there? And that tab is located right over the XT90 connector that's sitting in its own manufactured slot. Very tough to, I kind of tugged on it a little bit to see how loose it was, and this thing is tight. It's not coming out. And unless you really want to pry on it, I suppose, if you needed to. We have very thick wires here. This is a 10 gauge wire. So ample copper in there, I'm sure, to carry the 500 watts that the system can produce. And a very clean circuit board greets us when we open it up. Yeah, very professionally done here. And this is their own proprietary board. You can see down there that says SR, right, for Simrig. So yeah, they've done their own in-house, like all this stuff here, it's all produced in-house, except probably the electric motor and the gearbox they're using on their actuators. But everything else, in-house, so they got full control of what they're doing. And they made some good choices here. We've got some Rubicon capacitors, which are known as very good capacitors. We have 2 of them, 50 volts each, on each one of these driver circuits, because we have 4 actuators. We have 4 pairs of them. And I also really like that they've integrated these fuses into their circuit board. So each driver circuit has its own fuse. You'll blow the fuse before you burn something else up, which is always a good thing. So if an actuator just stops working and you can't get the software to recognize it, then I would suspect to be one of those. Just open the case, replace it, and off you go again. Pretty cool. And each one of these driver circuits has 2 integrated circuits over here for the power going to the, and the controller going over to the motors, because this is where the plugs are, obviously. And I was curious about these integrated circuits, so I went and looked them up, and I was happy to see that, yeah, they've done their due diligence here. These particular ones are configured to reduce the EMI of the motors and what's being produced here. So yeah, kudos to them that they're really doing a good job with their electrical engineering here, making choices like that. And what else can we talk about? We got an Amtel chip up here, up there, right there. And yeah, that's the processor. It's handling all the processor duties. And we have another capacitor up here, another Rubicon, that I'm assuming is the power circuit, the main power circuit there. We have a big transistor sitting there with the big soldered pads there. That's usually what that is, what that usually indicates. And yeah, so very clean. I like what I'm seeing here. These guys have done a great job, and it's one of the good things of being able to produce everything in-house. And it also has some kind of a serial number up here so they know which board it is. But yeah, not a whole lot else to see here. But yeah, I like what I'm seeing here. This is really good. I like this. They really thought this out well. So I'm getting even more excited about getting this system up and running. So yeah, that's it for the look inside of the controller box. Now the controller box is mounted to our chassis, and this is the configuration, or orientation rather, that the box is in when you look at, I'm going to show you a quick picture here of the PDF showing you how to mount this. So you want the power plug and the USB to be on the left side if you're looking from the rear. And of course on the other side we'll have the 2 other motor connectors and the emergency stop 2-pin plug. Pretty simple. Now there's 2 ways to do this. There's 2 holes. There's 2 smaller holes you see here actually line up with the profiles, but I would need 6mm bolts to get through those holes on either side. And I just don't have the T-nuts handy, and I did have some M8s, T-nuts, and some M8 bolts, so there's also the bigger holes in the center. So it does fine. It's not going to hit the ground because you've got your actuators in here, obviously, keeping everything up in the air. So yeah. So it's now that it's mounted, now we can start getting everything, actually just go ahead and cabling up everything. And I'll show you some PDF schematics, not really schematic, but the way they show you in the PDF how to hook this up. Very simple stuff though. And when we come back, we'll have the cables hooked up and see what that looks like. All the cables are connected and really easy to do as long as I'm going to show you a quick shot of the PDF here showing you the orientation of the cables. And if you get the box put on the back 40/80 profile like this, then it shouldn't be an issue. And of course we have the power plug plugged in now. We don't have the USB in, but I'm going to get that in a minute. And we have the other ones over here, and of course we have our kill switch plugged in over there. And if you look over, it's sitting over there. I'm not sure where I'm going to mount that yet. And we did some basic cable management here. Didn't want everything hanging down on the ground, although I suppose you could if you wanted to. And you see it right there. Get some zip ties in these very cool profile, and these are 40 series clips that you can use. And they sit in the profile like this. They have a little T-nut thing on the back of them. They just fit in there and you twist them, turn them 90 degrees, and they lock in. And then you can put zip ties in them because they have these cool slots in them. See those slots? And they have them on all 4 sides too, so you can go this way and that way with it. Very cool. As you can see, it really cleaned up the cabling, because there's a lot of wires in each one of these bundles. So yeah, definitely cleaned it up. And we have the power wire running the length over here on the left side of the rig, and it actually will fit into the bottom channel. Got it tucked in there pretty tight. And then I use one more of those cable management pieces and a zip tie to get it to come off the front. All right, nothing to it. So good, we've got everything wired up now. We are very close to turning the system on and doing a quick test to make sure everything works before I start putting the seat and the pedals and the wheelbase on here that we'll be using while we're testing the system. So here's the final testing configuration I'll be using, and just want to give you guys a quick flyby of what that is. Now remember, there is a weight consideration here, a weight limit of 175 kilos, or that comes out to 390 pounds. Right, so I've got a Prism seat in here with the JCL seating brackets. That comes out to about, I think that was like 23 pounds or something. And we're running the Simrig 2 Pro wheelbase with a stainless steel bracket, which comes out to about 23 pounds. And of course we have a Asher button plate sitting on a turn racing wheel. Or not a turn racing wheel, that's an OMP racing wheel. And we have the HRS quick release. And we're running the Wave Italy pedals down here at the bottom. And they come in about, I think they were like 13 pounds or about 6 kilos or so. So we've got some good weight on here, and I wanted to run, you know, a decent amount of weight on the system. With me today, I'm about 155, 56 with my clothes and shoes on. And yeah, so that should be plenty of weight to test this out. And I'm actually doing pretty good here, because the total chassis, I mean, combined, we're with the equipment you see here, I'm at 84 pounds. And because the chassis is only 43. So 84 pounds or 38 kilos total right now. And that leaves me 302 pounds and 137 kilos left over. And I'm 155 or so. So yeah, I'm still like 140 some pounds that left over, or like 100 kilos left over that I could use on this. So yeah, I like that I was able to get a decent amount of weight, but not too much weight. And I actually got one of my bigger friends coming by. Weighs about 230. I'm going to put him in here and see how it operates with him. But we'll get to that segment later when we do, probably when I'm doing the driving segments. But yeah, there it is, ready to go, configured. And yeah, so let's go ahead and take a look at the Control Center software. This is the Simrig Control Center application. This will be where we will be doing all of our tuning, and of course testing for the systems and profile management and things like that. So let's start with the first thing, which is start. And it gives us a system overview, tells us what our telemetry condition is. iRacing, we're currently connected. Devices connected to one device, which is the 4 actuators grouped into one device. And motion is enabled. You can disable it and enable it over here. Profile currently is iRacing's Porsche 991 RSR. Simrig SR1 calibrated and ready. Total runtime is 22 hours. So we've been putting some time on this system. Now we go over to where you're going to spend most of your time, which is going to be in the profiles. And you see there's some games here that I have on this particular machine, and it found them and listed them. We're going to go into iRacing. And you can see I've got some cars in here. And right now I'm on the Porsche 911 RSR, and there's a green dot next to it because the application knows I'm in iRacing, and that's the car that I'm in. Right. Now, if I was in a different car, let me go up to like the Ferrari, you can see that a little yellow bar clicked up here. So to make me being able to edit the 488 GT3, I would have to go over here and say edit the active profile, which is this guy. But I don't want to do that right now. So if you ever see that and you're on the profile that you want to edit, then you just click that and it goes away, and it'll look like this when just you do that. So let's go back to our Porsche. And this is the profile editor where we spend a lot of time. We can adjust your forces here, all forces, which covers all of the forces as a group. Or you can go into individual forces of acceleration, which is pitch backwards, braking, which is pitch forwards, turning, which is roll and left and right, of course, and bumps would be heave, amount of heave. So we can actually adjust that. Now this defaults when you get into a new car to 100% for all forces and 30, 30, 30, 30 for the other guys. The reason it's all 100 is because I was messing around with stuff and I can't go back right now. So of course I could just do this down to, and like I said before, just adjust the sliders to wherever you want them to be, or you can actually highlight it and type in what you want. So yeah. and I'm at 101 now. So all of that's going to change once I do my tuning session. I'm going to do a brief auto tune and tuning session on this on the next segment. We're just going to go over what you can do with the controls here. Axis allocation, that's simply giving the movement allocation to where you want it. You can have more pitch, you can do more roll and pitch, or more heave, stroke length, and it's what's cool is they've got all these pop-ups here that tell you what that does or what it's supposed to do. So yeah, axis allocation is basically we have 100% of travel and we want to allocate pieces of that to our roll, our pitch, and our heave. Now, we'll go down to orientation. Again, this is a fine tune, and if you hover over that, it says follow track geometry on the roll axis, which I'm guessing that's what you will want to do. Recommend value is 20. Of course, it's 0 right now. Pitch is the same thing. Follow the track geometry in the pitch axis. Right. Gear retention, that's all about the gear force, how it hits you, how long you want it, the duration to be. Right now it's 200 milliseconds, and it's at full force at 100%. Hardware responsiveness, this is, it controls the actuators to how they respond to changes in the target position, and just increase it for faster response, decrease for slower. Right now it's at 100%, and you see it's all the way over here to the left. If I move that up, I can actually amplify it even over 100%. I leave it at 100% usually. Right, post-processing. This is a filter, low-pass filters that we're able to use to do different things and really fine-tune our configuration. And of course, the one that we're going to be using a lot is auto-tune, because the company Simrig guys all say, look, you need to auto-tune everything because it doesn't, it really doesn't move that much until you do auto-tune. And I'm going to demonstrate that, or try to demonstrate that in the tuning segment. I'm going to do a short tuning segment on using auto-tune. And here you have your stop button, your reset, so you can reset whatever you just captured if you don't like it, and apply, and that will apply it. When you hit apply, it applies it up to the top here to the forces. And all these sliders here will change based on the telemetry that the game picked up while you were doing your session. Now, they say they want you to do around 5 minutes of collected data without, going off track, hitting walls, things like that. That would not be very good information. But I do a couple laps around Sebring. It seems to work fine, and that's about a little over 4 minutes. But we'll see how that works later. All right, so there it is. And of course, we can actually go in here and make copies and edit things. We can activate copy values or paste values I've already copied, duplicate, which you might, typically that's what I do. I'll duplicate, and then I'll rename it for like the same car but a different track, and then tune from there. Delete it if we don't want it. I'll go up here. I don't want this one anyway, this copy I just made. And we go ahead and delete it. Yes, I want to delete it. And I got rid of my copy. So yeah, this is, again, in rename, whatever you want to do here. So yeah, very cool that we can edit all of our profiles in here. I'll go ahead and click on the Porsche again. And then we go to devices, and this is where we can do some testing. Launch the Axis Tester. I'm going to launch that. Basically, it just proves that everything's working like it should. You hit enable, then we'll get a couple of lawyer warning nags, screens pop up. So there they are, warning you, don't, watch out, it's going to be running. Full speed, that makes it run faster. I just usually leave that off because you don't need that really for, seeing if it's moving or not. So I'm going to pitch forwards, and that's to the right. And you can see I'm pitching forward, and I can pitch back like that. Going off, taking off to a rocket ship. All right, or like a rocket ship. Okay, so we have roll, and we've got some movement. We got some range of motion here. You see I'm rolling right. I roll all the way back over to the left. And you can recenter with hitting the center button. And heave is up and down, of course. Elevator up, elevator down. All right, through this whole travel range. All right, so everything's working well, so I'll go over to my load estimator now. Now, this is a cool little tool that will, again, in the instructions, you'll see them say it a couple of times. They want you to be a 50-50 weight load between the actuators, which probably you're not going to be able to get. Or maybe you'll get lucky and you will, but it's going to be hard to get that, but get very close anyway, because you don't want more load on the front actuators than the rear for long periods of time, because it's going to be wearing the back ones or the front ones out first. Load estimator, so I'm going to go ahead and run this. And it's going to go up and down, and I'm not sure how accurate this is because I am sitting in the seat kind of in front of the rear actuators and behind the front ones. And we do have a SemiCube 2 Pro wheel up here and some Italy Wave pedals. But yeah, let's go ahead and do it. And again, our little lawyer nags here. There we go. So you see it go up and down. And it'll keep doing that as it estimates the weight. And of course, I'm 156 pounds sitting in the seat close to the rear ones. And it's still showing me that I'm about, 66, 34, whatever. It'll do this whole test and then it'll stop. But it'll tell you what it is. Again, I have no way to know exactly how accurate this is. I'm going to take a scale and measure under each foot of these actuators and then see if it's the same, what it's saying here. So that's the only one way really to prove this. Now I can go ahead and get out of this. Now here we have a high frequency control. You want to enable this because if you don't, the motors have this high pitch. Yeah, I don't like the noise. It says that some people will like it, some will find it annoying. I find it annoying, so I always enable it. It keeps them quiet because you just heard they're not that loud when I was doing the load estimator. Keep level is another thing you want to enable. That keeps the cockpit level all times. When the power is on, you turn the power off and it settles down. The actuator's kind of, it'll go forward or it can go sideways or something like that. But yeah, I like to enable that so it's level all the time, and currently it is level. Right, so that's about it. It's a pretty simple app to use, and if you have any kind of questions about the app, let's go back to the profiles, and I'm hovering, let's see, I'm going to go up to the top where it says read more, and it's the instructions. If you click on that, it brings up their website, which has an active user manual. Here it is. And this is on the profile page because that's where I clicked. And it gives you more details about what you should be doing and how they want you to do it. And yeah, the auto tuning, they go into detail what they want you to do on the auto tuning and how many minutes of data they want you to collect and stuff like that. So, and it also has other stuff. It has a quick start page for just getting started. So it's a good online document, and I kind of like that it pops up when you need it and it's not there when you don't. So I'm going to close that back up. Right, so yeah, that's about it for as far as the control center is concerned. And next what we'll do is get in and do a quick tuning segment using the auto tune, showing before and after and seeing what the differences are. Alright, so we're back in the control center. We're going to do an auto tune session. I've just gotten into the Porsche 991 RSR here, and I haven't done any laps in it, so I'm going to go from a default mode when you first get into the car. And for the first time in iRacing or any other game, it creates a default profile. And if you look up here, it says 30%, 30%, 30%, and 100% for all forces. So I'm going to go down here and start my auto tune. All right, first I'm going to hit reset and make sure I didn't change anything up there. Nope. Okay, now we're going to start it. And what I'm going to do is take the Porsche out and do a couple of clean laps. Remember, we just want to do some clean laps so we can still go over rumble strips and things like that. You just don't want to go off track, hit the wall, do anything crazy, or any of those really big sausage curves. You probably don't want to go rolling over those. But yeah, just keep it simple and a couple of clean laps. And I'm going to show you guys a clip of me doing the clean laps and watching this suspension move versus once we've finished our auto tune. So I'm going to go ahead and do a couple of laps and we'll come back and see what that looks like. So I went out and did a couple of laps, and you can see that I have 3.3 minutes of collected data. And again, they say 5 minutes is better, but I just want to give this a quick test just to show you guys how this works. And if you look at the previous screen, you'll see, and remember that it was all 100% down here. Now it's 159, 61, 53, and 225. So things have changed. And if we go up here and look, it's still 100, 30, 30, 30, 30. And it won't change until I hit apply. So I'm going to apply what this telemetry told the algorithm that runs this on what should be happening with the car. So I'm going to go ahead and hit apply, and then we should be able to roll right up and see that it's changed, and it has. We're still at all forces 100%, but now those numbers have transferred and replaced those 30s, percentiles that were in there. So now let's go take this thing for a ride and see if we can see any difference in the way the suspension is responding. Here is a side-by-side comparison I thought I'd show you guys. Probably the easiest way to see the differences before and after the auto-tune. And obviously right away you can tell that there's a lot more movement going on the frame on the right compared to the left. And the one on the left was the original configuration when I had never been in the Porsche before and loaded up with a game. And yeah, all 30% on all the windows or fields for the acceleration and the roll and braking and all that. Yeah, it was a big difference, as you can tell. And the thing is, some people, this is a great feel for them if that's what they want. But for me, I tend to, in a GT car, it just doesn't seem to me that the suspension is going to be that drifty and rolly. And so I usually take that all effects slider and just turn that down for the total effects to about 75% after an auto tune. But that's just me. And of course, all this is very subjective. if this is the way you want your cockpit to react to whatever car you're driving, then that's fine. And you know, when you're in something like one of the dirt trucks, and I'll show that during the driving segment, then a lot of movement like that is probably what you want, or a rally car maybe. But when you're in a track car, it just doesn't seem quite that it should be pitching, like you saw how much that pitched. It shouldn't be pitching that much, and leaning way back when you accelerate. So if you guys can, like I said, just watch these two running together here, and a real big difference. And road bumps are a lot bigger when you're going across the road bumps with this. So yeah, just want to go ahead and show you guys this is the differences. And again, from here we tweak to your personal taste. So now we'll just get on to the driving segment. Now for a moment of silence. So yeah, I'm just going to do a little test here for a couple minutes, let you guys sit back and listen to this chassis as we go over jumps. Okay, so you guys make up your own mind. Is it quiet enough for you? I think it's a pretty quiet system. I've definitely heard louder. So yeah, I think most people would be happy with this noise level. So here we are in iRacing, as usual, at Sebring, and we're in the Ferrari 488 GT3. And this is right after an auto tune, and I was just playing a little bit with the overall forces slider, reducing it a little bit. I think I had it down like 90% just to see what the difference was. And it's still a bit pitchy for me. Roll's not too bad. The heave I think is pretty good, but it's just the braking and acceleration pitch here is just a bit much, and I ended up going down to like 75% to get it to feel like at least what I think a GT3 car it should be doing, as far as how much nose over or how much the nose goes down when you get hard on the brakes, because their suspensions usually don't have that much travel in them. And of course it's all subjective. You tune this thing any way you want to. I mean, it's got 70 millimeters of travel, so yeah, why not use it if you want to? So yeah, it's you really can't complain about that. I'm going to give you guys a shot from the rear here a little bit to see what's going on, and you can see it's, you know, how it's moving on the pitch. And like I said, it's really, you know, we're talking about a system here with a cockpit, for crying out loud, for under $4,000, well under $4,000, and it's just amazing to me to see that this kind of system can be had. And you know, it's got 3D printed parts on it, you know, and it's got its own proprietary system set up as far as the way the mechanicals are working. But the guys, I think, have done a really great job to be able to bring this thing in, and in the way it performs so far, as long as I've had it so far. And yeah, it's just, they've done a great job here, the guys over at Simrig. And of course, Swedish Rig Designs, SRD, did a good job getting this lighter profile cockpit system put together for them, so that all this would come together, and it is what we see today. Now, of course, I'm a lightweight guy, 155 pounds, with clothes and shoes on. I went ahead and let one of my friends get in this, and he's 230 pounds. So I wanted to put a little more pressure on the system, if you will. And of course, this is just a road car. I didn't put him in the Lucas truck and let him go over a bunch of jumps. But Yeah, it handled him pretty well. And again, this is the kind of thing that we like to do with the SRG. We like to push it a little bit and, you know, see what these things are made of. See if we can, under normal use. I mean, somebody who is 230 pounds getting in this, I will consider normal use because they're still not quite over the 175 kilogram all-in weight limit that this system has. So yeah, with him in it, I think there's about another 40 pounds left before we get to the 175 kilograms or 390 pounds of limitation here. And he had a blast in it. It was hard. He said he couldn't believe that this thing is the cost of this thing, and considering what, you know, like a D-Box or some of the other stuff runs, yeah, he was pretty happy with it. Now we're going to go ahead and push a little harder myself, and we're going to get into the rally car. And yeah, again here, it's just a blast. I mean, there's so much fun to be had in the rally stuff when we're jumping that yeah, you can see the suspension working pretty good there on the landings, and yeah, it's just a lot of fun. If you've never been in a suspension system that had some travel, or just a suspension system rather that has the travel that these do, yeah, it's just a blast to get in here and do the jumps and the rallying. Even though we don't have the yaw access, which would make it more complete, no doubt. But yeah, we just don't have that here, and yeah, even without it though, it's just like a 4-actuator, any other 4-actuator system out there. We're going to get our heave, we're going to get our roll and our pitch, and of course the heave with 70 millimeters of travel here is doing a good job as far as when we're actually going over the jumps, and then we're coming in for the landings. And here I don't mind the pitch that I'm getting and the roll I'm getting, because these kind of cars obviously have a softer suspension than say a GT3 car would have. And then of course we have to go over to the Lucas trucks for the final testing. And again here, I spent a lot of time with this system here, and you know, pounding on it, going over the jumps over and over again. I think I have, it says I've got like 20 hours. I don't think I have that many though. Anyway, it says I have 20 hours on it. They may have put some hours on it before they sent it to me, but I've got some hours on it, no doubt, doing just this kind of thing. And yeah, going over these big jumps like this one and sailing through the air and landing. You do that over and over again, it's going to put some stress on the system, no doubt. And I actually checked the motor temperature. I could reach back and touch the motor behind the 3D printed cover they have for it. And you know, the motor gets warm, but it doesn't get hot to the touch or anything like that. So they've done a good job with this system. I really don't have too much to complain about. You know, it's just one of those things that for the money that this thing costs and they're coming in at with, it's just amazing to me that they can do this. And it's, you know, happy to be around long enough in the sim racing world to see these things go from some uber expensive systems to, yeah, somebody can get a 4-actuator system and a chassis for, you know, again, well under $4,000. Yeah, I'm loving this because it's going to open it up to a lot more people out there who want to have a 4-actuator system in their home to have a lot of fun like I'm having fun here. All right, so yeah, what we'll do next is get on to the next segment. I think I'm going to do a sound test on this and let you guys hear that before we get to our final thoughts. Final thoughts on the SR1 motion system from the guys at Simrig in Sweden. Here we have a 4-actuator motion system that uses 3D printed parts along with Delrin and aluminum to create an actuator that has some pretty good specs. With a 175 kilogram load capacity, 70 millimeters of travel at 100 millimeters per second. which in use gives the sim racer a great motion experience. I like the tidy and professional layout on the Simrig proprietary controller circuit board, with nice features like fused circuits and an integrated driver chip that is optimized for EMI reduction. All the cable is nicely done with industry standard terminations. Now, there is no shielding on these cables, which I would like to see, but I'm sure this does keep the cost down. And I didn't have any EMI RFI related issues. I also like the custom design bits that can be found throughout this kit, like the 3D printed casings on the Meanwell power supply and the upper actuator support brackets. You can tell that Simrig put a lot of time and effort into bringing the SR1 motion system to market. The Simrig Control Center. The tuning application is a well-developed piece of software. It has a user-friendly GUI with some rather nice pop-up screens to guide you through its use. Easy to manage profiles make customizing your setups for each car and track, pretty easy. Now, driving this system is a treat, and getting up and running with the auto-tune function couldn't be easier, I think. Although I think the algorithm they are using here is just a bit over-aggressive on the travel settings for the more tightly sprung cars out there. But, of course, it's easy to dial it down to your own personal preferences. Once that's done, you are set to have some real fun here. Everything from circuit cars to the high-flying dirt trucks gives you a satisfying experience. Now, with a weight limit of 175 kilograms all in, you will need to take care in selecting cockpit materials and, of course, the hardware that you're going to be running. But even with the heavier kit I was running, the SR1 was able to handle a 230-pound or 140-kilo driver without any degradation in performance, at least any that we could detect. Of course, I can only vouch for actuator durability for the time that I've been running this system. But the SR1 does come with a 1-year warranty. You know, overall, I like what the guys at Simrig have come up with here. At a non-VAT price of 2,320 euros, I think anyone can see this will be a very desirable setup for a lot of sim racers. Unfortunately, this system is not currently shipping to North America, but Simrig tells me that this will be sorted sometime around the third quarter of this year. I'm Barry Rowland. Thanks again for watching the Sim Racing Garage channel. Don't forget to hit the subscribe button, and if you would like to help support what I do here at the SRG, visit my website at simracinggarage.com.